back to another episode of Trying to Learn C. This is episode 11, and I'm going to continue from where I stopped. So, through the last 10 episodes, we have done 16 programs. So, I'm going to continue from number 17. Create a program to find the smallest and largest element in an array. Let's get into it. So, for each project, I create a separate directory. Then, you can just name it large, small. Don't mind the names. I'm just then I will open my main C file, my main function. Okay, so largest and smallest array. So I'm going to have two functions that will each take in arrays and argument and spit out the largest and smallest. So let me just do largest, then this is the array, then you have smallest array. I can even make it one function, but then let me just do it this way. Then maybe this is your array. Let's say 1 2 5 65 56 90 34. Then let me create the functions here. Then you have array here. This is for the largest. Then you have smallest to print out the smallest. And also I need to pass in the length of the array. So I can just do int I can ling length is equal to 1 2 3 4 7. Variable size. Just do it this way. 7 7 7. Then here each one is going to take in a length parameter. Alright, so to find the largest, it's pretty straightforward. Just a for loop. I is equal to 0. I is less than length. I plus plus. So here we can just do int large. We can just do int largest. That's where we'll store the largest. It's largest. Then how we start? We make the first element to be, no, that's not. Instead of using for loop, I think I'll use while loop. So we go while int r is less than length equal to 0, while l is less than length. Then you go largest is equal to at I. If would this work? I don't. Why I want to do it this way is I don't want the loop to be going over and over again. I want it to be optimized. So I'm thinking of the best way to achieve that. Or I can do int. I can do bool looped is equal to false. Then I can do while looped, that means loop hasn't. Then at 0, okay. So we can do std bool, alright. Then 3 if is equal to 0, is less than I plus plus if largest if at I. So I can just change this to 1. Area at I is greater than largest, then largest to be equal to the element at position I. So this will only go once, I believe. Then you can just printf percentage d largest is the largest. see. I forgot one important bit. After this for loop, then we now change the value of looped to be equal to true, so it doesn't go on forever. 90 is the largest, so that's in the middle. So let me just introduce one more at the end here and see how that's. I mean that 91 is the largest. Okay, what of at the beginning? 0101. 101. 101. Okay, that works. So the reason why I did it this way is because this is only going to run once, I believe. Because let me show you something. Just to prove my point, I wanted to show an example, but let me just explain it. If initially what I wanted to do, maybe two nested loops, but the problem with this is when this finish running, it will go on and this will continue, then this will start again, and it's just be too much. So I opted to do it this way. So this while loop will only go once, because at the end this gets triggered and the while loop breaks. Or I can just do, I think I can even do it this way. Let me try this. Oh. So let me see, what if I do this? Oh, so I don't even need the bool, so I can just leave it at this. So while one, so this while loop will only run once and break. This for loop will just run till the just the length of the array, and compare everything with the largest and break. I think this is it. Then for the smallest, I can just copy this code. I can just smallest, then smallest, then we just so when we do this we should get 1. So let's see, that was straightforward. 1 is the largest, 1 is the smallest. So that's it. Think I am done. Create a program to find the smallest and largest element in an array. Yeah, so I am done. Let me just then git add, git commit largest and smallest done, then push. Now I can just come here. Done. Write a program to add 2 matrices and another to multiply 2 matrices. So let me just go KDIR matrices, KDIR matrices, then CD matrices, nvim main.c creates my main function, then add and multiply two matrices. So I am coming. Matrices addition. Let me just check how the addition is done. So matrix A plus B is equal to matrix addition, the addition of two or more matrices, or like addition of numbers. Addition will follow different rules. The order of matrices should be the same before adding them. Before going into the addition of the matrices, let us have a brief idea of what are matrices. Blah 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 blah. Addition is the basic possible. Okay, addition is possible only if the order of the given matrices are the same. By order we mean the number of rows and columns are the same for the matrices. So so it has to be the same size. That's it here. M by n, m by n. So if my matrix A is 1 times 2, matrix B should also be 1 times 2, 1x2, which is 1 row, 2 columns. Okay, this is it. So suppose we have this people P and Q. So you see 3, this is a 3 by 3 matrix. This is also a 3 by 3 matrix. So it is possible to add them 3 by 3, 3 by 3. So how we do it is, it will now be what is at this position plus this position, 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 this position plus this position. Alright. So how do I represent matrices? I think I have to use arrays. Maybe array of arrays. Yeah, that definitely has to be it. So let's say matrix A would be equal to then 1, 2, 3. So if I have something like this, this would be 1 by 3 matrix or 3 by 1. Yeah, this is a 1 by 3 matrix. It has one row, which is, it goes like this, and then 3 columns, 1, 2, 3. Coming, one row, which is like this, and then like this, and then 3 columns. So which is 1, 2, 3, 1, 2, 3, one row, 3 columns. Yeah, so this is a 1 by 3 matrix. So let's say I don't want to do a 3 by 3 matrix. How do I do it? So that's another row and another row, 3 by 3, each would be possible. I can 1, 3. Okay, what is this arrow? Oh, are they supposed to be like this? Okay, I think it's actually not as simple as I thought it would be. So let's go arrays. So let's go matrix representation in C. Let me see how. Oh my god. I think so. If I do this, then can I do this? So let's go 3 by 3. Oh, so I have to do this. My bad, my bad. So if I do this, it will allow me to create a 3 by 3 matrix. So we have 1, 2, 3. Then we have this. That's the first row. Then for the second row we have 4, 5, 6. Then for the last row, 7, 8, 9. So this is a 3 by 3 matrix. So that's how we should be. Alright, I need to be able to print the matrix. The matrix is fine. So I am just going to create a helper function to help me print it to be visually the way I want it. Fun print matrix. So to take in mat. So let's say by 3, 4, int I is equal to 0, I is less than, so I can just do int length is equal to 3, I is less than the length, I plus plus. So what is happening is, so during our first our first loop, it is going to grab this, then we cannot print them in a straight line. Yeah, then we can do for j is equal to 0, j is less than length, j plus plus, printf, mat, then you have j, no, this isn't how I want it. You can just do percentage. Alright, remove the new line, add a bit of space, and this should print it. Then here we can do printf, and we go percentage, not percentage, sorry, add a new line, I think this should do it. Printf, sorry about that, print matrix, right here. Okay, let me see how that goes. Alright, this is it. Okay, so I have that out of the way. So now we have matrix A, and then we'll have matrix B, int mat B. It also has to be a 3 by 3 matrix. Well, let me just do random numbers. Okay, that's not very random. Alright, so then here we can have a function. Function, just yank this. Then we go add matrix, add matrices. Then here we can go add matrices, and it will take in mat A, mat B, and then mat B, which also happens to be a 3 by 3 matrix. Okay, we'll go length is equal to 3. So how, definitely a for loop, int I is equal to 0, I is less than the length, I plus plus, I then a second for loop to get int j is equal to 0, j is less than length j plus plus. So this is where we can add the elements. Oh, so I think let me just I think I need a new variable results to store the results in there, which also has to be a 3 by 3 matrix, because when you are adding, you should get back the same size, the same matrix size. So if you're adding a 3 by 3 with a 3 by 3, your result should be a 3 by 3. Simple as that. All right. Then we can now do results. Then we can do I j is equal to mat a I j plus mat b I j. Okay, this should work. Then we print out the results. So let's see what happens. How do I know if it's correct? I think I can just do it, or we can do it together. So we have 1 plus 2 3, then the second element 5, the third one 4, then 7 11 8, 7 plus 8 15, 8 plus 4 12, 9 plus 7 16. All right, so that's it. That was easier than I thought. Then we can do multi. I'm coming. Let me just yoink. Let me just yoink. Multiply matrices. So this is our multiply. Then we can do this is I am just doing the boilerplate. I have to go check how matrix multiplications are done. Then okay. So let's see. Multiplication. A matrix, specifically linear algebra. For measuring the number of columns in the first matrix must be equal to the number of rows in the second matrix. Wow. Has the number of rows of the first and the number of columns of the second. So this is it. So you have m, this is m by n by p, which would give you m by p. So the column, okay, so when you're multiplying, so when you're multiplying a matrix, let's see, you have a matrix, okay, which is a 3 by 2. So, and you have another matrix, this is matrix A. Then you have maybe like a 4 by 3. So based on what this is saying, based on how it is done, this is not possible, because the column of the first matrix has to be equal to the row of the second, and here not equal. So that's why you see n and n here equal, and this one can be anything. So here this has to be 2 matrix. So multiplying a 3 by 3. So if I should multiply this a 3 by 3 times a 3 by 3, I should get back a 3 by 3. But so this is it. Okay, let me. Okay. Okay, so at any position, let's say C11 is the summation of all the rows, the multiplication of all the rows at that position. Is that it? Because I need a visible example. Let me see. All right. Let's say no, not this. Multiplying two matrices. Yeah, this would work. So AB. So for the first position, 3 times 6 plus 7 times 5. So we are multiplying this times this. That's for the first position. Then for the second position, you are multiplying 3 times 2. Oh, so how it is done is if you have two matrices, you take the first row of the first matrix and you now, mm, if you take the first row of the first matrix, you now multiply it by, sorry, to get the first element of your result, which is A times B, this 53, to get this first position, you take the first row of the first matrix and you multiply each element with the first column. So 3 times 6 plus the summation, 3 times 6 plus 7 times 5, get this position, in this position. Alright, I see. So since we are multiplying a 3 by 3 matrix, our results will also be a 3 by 3 matrix. I'm coming. Let me just yoink this. Yeah, that's better. So it goes through the loop. So it takes the let me also yoink this. Alright, so now we are inside. Then we can do results at I and J to be equal to okay, this is actually tricky. I'm going to create a helper function that will take in this and just spit out the results. Take this multiplied by this times this multiplied by this plus this multiplied by this plus this multiplied by this. Yeah, that's what I'm going to do. So let's come here. Is equal to let me just call it row column multiplication. That's an awful name. So it will take in I'm sorry about that. Will this even work? Can I extract array? If we go the first row would not be I, a 3 by 2 matrix. No. What do I do? I am thinking, how do I do the summation? This first loop, they are working with this. I am coming. Let me just come here. No, that doesn't work. This, sum it with this, take it and sum it with the next one. So for this I take this, multiply and sum it with this to get the first element. So which is 0 0 times 0 0 plus 0 1 times, sorry, wait, I think I'm coming. So you have this AI, so it is so A11 times B11 plus so like this A11, which is this. This is your first row, first column, first row, second column, A11, A12, A13, A11, A12, A13. Okay, then this one is B11. Okay, A11 times B11 plus, let me write it down, A11 times B11 plus A12 times B12, like this. That's A11 times B11 plus A12 times B12 plus A13 times B13 plus A13 times B13 C11. A11 times B11. Okay, 2 to 3. This is actually B11, then B21, then B31. Yeah, this is it. Okay, so if we loop the first time, we get each of the columns. Access to the rows. Column rows. One column, one row. Let me try something. Let me see if I can. Can I print? Can I print? I wanted to see if I can print a certain row. If I can do that, not the element. Matrix. I don't want to get the whole answer, so let me just see. Matrix representation. See if I can get something. result I comma j is equal to no, this is not it. I comma j is equal to, so I comma j would give you, let's say, 0 comma 0, then times, so I think I need to let this ij wait. Let me try something. So let me just do, let me change this to k, k, k. Then here I can do since we do a11 plus b11, so a11 plus b11 times a12. Come on. I need to think. So you have this. I thought of something, but I don't think it will work. 0 comma 0, that's your first row, first column. Take that element, then 0 comma 1, take that element, take this element, multiply by this, take this element, multiply by this, take this element, multiply by this, add them. So this doesn't change, this doesn't change, 0, 1, 2. Let me just try something. I've been saying let me try something, comma j is equal to mat j k. So let me try this and see what happens. What gets printed out? 3, 5, 4, 7, 11, 8, which is what? 3, 5. So 3. Oh my god. So we have 3, then 5. No. 3, then 5, 4, 7, 11, then 8. I don't even have 11 here, but oh, I don't even call the matrix. Oh, what the heck was this one that was wrong? My bad, my bad. What the heck was that? My bad, my bad. 369, 369, 369, 369, 369, 369. Okay, I am only getting this. I believe they get overwritten, so this gets called this one, 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 this one. This should be RK J, comma K. Let's see now. 1, 2, 3, 4, 5, 6, 7, 8, 9. This first matrix. So I am just trying. I don't know what to do. I am just trying out a few things. Mat A at J, comma K. New line. Main.c. Oh my god. 1, 2, 3, 4, 5, 6, 7, 8, 9. So 9. 1, 2, 3, 4, 7, 8, 9. 2, 3, 9. This is the first row. First row. It's first column. That would be the first column of B. Second column. Third column. I'm thinking of something. This. Okay, I think I have it. Come on. I just thought of something. Would be equal to so here can just be plus mat A I, then G, 615 9, 615 15 9, 7 8 16, 7 8 16. I got something wrong. Here I can just do results I j is equal to 0, just to get a clean slate. Okay, this looks no. So what is happening here? Let's see. So let's say your I is equal to 0 and your j is equal to 0. So you can do it. So you will do results at 0 0 would be equal to maths I comma j, which is 0 0 times 0 math 0 0 times j comma k, which is 0 1 2 3. No, that's not how it should be. Here would be j. Okay. Oh my god, 136 424. I got this diagonal. I am actually happy. What the heck? Okay, I think now the problem is this. When I is equal to 0, this is 0. To get that, j 0 1 is equal to 1. J. Okay, like this. 180 259. Do I remove this? Let me see what happens then. Let's go over it again. When I is equal to 0 and j is equal to 0, you enter this loop. 0 0, which would happen 3 times. So you have 0 0 0 1 and 0 2. 0 0 0 1 0 2. Okay, is equal to, and what is this? K plus plus j. So let's say 0 times k, 0 0 0 0 times a11. Let me just okay. Let me just change this. I think this is a bit easier to read, to understand. So we go at jk, then you have a say 1 times b 1 1 plus a plus a 1 2 times b2 1 plus a1. Okay, check on my game. RJ. Okay. Let me try this. Six for uniform. I think the problem is with how I am assigning this. I think that's where the issue is. Let me try something out. Let me int r printf percentage. I just want to print out my r and see what I get. So I would make this to be equal to r. Yeah. Then I'll comment this out. New line. Just to make it. So after every 136 560. No, that's not it. So we can come up here. R equals 0. Yes, okay. Let's see what we get here. 136 459. Alright. Let me see. So the problem is not from how I am assigning the result. I think that's okay. JK KJ. This looks very correct, at the same time wrong. Matrix multi application in C. So let me see how it is done. I don't think I will get it. the correct thing? Oh my god, that would be crazy if that was just what I missed. Oh my god. What? Oh my god. I tried. So this was the only thing I was using G. So why is it I and not G? Let's find out together. So all this thing is for the first row. So it will not be first row at which position? 1, 2, 3. Then you go on to get this. IG. Let me see. I actually tried, but then I need to know why it is like that. So because you're multiplying A11 times B11, so A11, okay, this 1 is constant all through until you move on to the second row, and then you now continue. I think that was what I missed. This is it. So I'm going to stop here, continue here next episode. Let me mark it as done. It was actually fun. Commit, matrices, calcs are done. It was fun actually. I enjoyed the math. But so use of pointers. So I am going to start pointers next episode. So till then, adios, my friends.